So this is level 2 D Algebra, and this is the first exam in that book for 2018, and this is question 1D and E, which are both excellence questions. So question 1D is a really, in fact, they're both really common excellence questions, so it's worth practicing quite a few of these. There are a few more like this in the Walker book too, and in the Theta textbook, as well as past exams. So the key is always when you get a word question, read the goal first. So the goal is at the end, and it says find the height of the mirror including the frame. Now we want to start the question really clear on the fact that that's our final goal, and in fact I'm going to draw that in so I don't forget, because you could easily forget that and not fully answer the question. So this is my goal. I need the total height. So okay, now I'm going to read through the rest of it and I'm going to underline as I go. A mirror is twice as high as it is wide. It has a wooden frame which is rounded at each corner at the top and base, and we can see that. The width of the frame is 9 centimeters, and they've told us that in the diagram as well. The area of the wooden frame is the same as the area of the mirror. So same as, so equals the area of the mirror. Okay, and we've got to find that height. Alright, so once you've been through and underlined it, it doesn't hurt to read through it again. So maybe pause the video and do that. And then what we want to do is we want to start putting together our equations. It's got to be an algebraic, or it's got to be algebraic equations, doesn't it? So if we go through the information at the start, first thing that allows us to write an equation is where? It's the first sentence. A mirror is twice as high as it is wide. And we can see they've called the height h and the width w. So we can write that. So twice as high as it is wide. So the height is twice the width. Always just stop and check that you've got that the right way around. And we can see that the height is the longer dimension. Okay, the next thing we're told is that allows us to write an equation is that the area of the wooden frame is the same as the area of the mirror. So let's just start by writing an expression for the area of the mirror. So mirror, its area equals, and it's just the height times the width, isn't it? So height times width, or width times height. And then the area of the frame, okay, so the frame is made up of some pieces, isn't it? So let's think about the pieces. So first of all, we've got the vertical pieces, right, these ones. And, okay, and they're rectangles, obviously, so that's going to be length times width again, width times height. And in this case, the width is 9 centimeters and the height is h. So we'll start with that. So area of frame, and we'll start, so the vertical piece is 9 times h, but there's 2 of them, so it's going to be 18 times h. And with the width, there's two horizontal pieces too, aren't there? So the horizontal pieces, again, their width is 9 centimeters and the length across is w. So it's going to be 9w, but there's 2 of them again, so it's going to be what? 18w. Okay, now what? Well, we've got the 4 corners. Now, each of those, they've given us the formula for the area of a circle, so that won't just be for fun. So, obviously, they're expecting us to think of those as quarter circles. So, if we combine them all, we get what? A whole circle. And the radius of that circle, if we put those pieces together, right, like this, then the radius, that's a terrible drawing, the radius is going to be what? Well, it's 9, isn't it? It's 9 centimeters across, so the radius equals 9 centimeters. So we're going to be going plus pi times the radius squared, so pi times 9 squared. And that, can we simplify pi times 9 squared? Yep, it's just 81 pi, isn't it? Okay, now what? So now we've got to remember we're told that the area of the wooden frame is the same as the area of the mirror. So we can put this together, can't we? So we can say the mirror area, HW, equals the frame area, which is 18H plus 18W plus 81 pi. Okay, now, what do we do from here? Well, okay, I want you to pause the video and I want you to have a think about it for yourself. Okay, and if you've just been watching this, what I want you to do is, before you hit play again, I want you to write down everything we've done so far and actually have a wee go yourself from here, because you'll get a lot more out of that than just by watching this. Okay, so what we want to do next is, the problem with the moment, we've got two different letters, H and W, so two different types of unknown. So we want to eliminate one of those or reduce it down to one letter. How can we do that? Well, the way we can do it is we know the link between those letters, those variables. H is 2W, so we can substitute that. We can substitute 2W in wherever it says H in that equation, can't we? Okay, so let's go ahead and do that. So instead of HW, it's going to be 2W times W. And that equals, instead of 18H, it's going to be 18 times 2W plus 18W plus 81 pi. Okay, and we can simplify that, can't we? So 2W times W is just 2W squared, and that equals 18 times 2W, so 36W plus 18W plus 81 pi. And simplifying that again, we can collect like terms here, can't we? What are our like terms? Well, 36W and 18W, they make 54W, don't they? And then so now we've got a simpler equation. Okay, what sort of algebraic equation is this, folks? Well, it's a quadratic equation, isn't it? And when we see a quadratic equation, in order to solve it, what do we need to do? Well, we've either got to factorize it, or we've got to use the quadratic formula. And you can always use the quadratic formula. To do that, you need to get it into what form? Well, we need to get it into the form a times w squared plus b times w plus c equals 0. So we need to find those numbers a, b, and c. Because normally it would be x, right? But we're just using w instead. Okay, so what do we need to do? Well, we need to get it to equal 0, and we need to get all of the terms in that equation over to one side. So always go carefully here, because this is where you can easily drop a negative, you know, get the negative and positive around the wrong way. So always get it so that the squared term is positive, okay, if you can, because that makes it easier. So 2w squared is going to stay on the side it's on. Now, I've got to take away 54w from both sides. So it's got to be minus 54w. And same thing with 81 pi. I've got to take it away from both sides. So minus 81 pi, and that equals 0. Okay, and now what have I got to do? Okay, I've got to, well, I can use the quadratic formula here, which is probably going to be the quickest way. So let's go ahead and set that up. Remember, that gets given to you on the formula sheet, right? But it's actually not a bad idea to memorize it anyway, which you'll find you do if you practice enough examples. So w equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And substituting in, and what we want to do is we want to actually write off to the side what a, b, and c are. Okay, so a equals, what does a equal? A equals 2, b equals negative 54, and c equals negative 81 pi. Okay, substituting that in, and just always, guys, always write down the working for this before you reach for your calculator. Because the thing is, otherwise, if you try and do it all in your calculator at once, that's when it's so easy to make a mistake, because you don't have something in front of you to read off. Okay, so I'm gonna go ahead and actually write all that in. So w equals, instead of negative b, it's gonna be positive 54 plus or minus the square root of negative 54 in brackets squared minus 4 times 2 times negative 81 pi, and then that divided by 2a. So 2 times 2 is just 4. Okay, and before we grab our calculator, it's actually really good practice to put brackets where we're going to need to put them on our calculator, because that just helps avoid silly mistakes. So I'm going to, even though in our algebraic working we don't need it, on our calculator we're going to need to put brackets here, here, where else? Under the square root sign we're going to need brackets to tell the calculator that we're square rooting the answer to that. And then now I'm okay. So now when I grab my calculator, it's just a case of reading it straight from what I've written. Okay, so let's go ahead and do it. And being careful that what's on my calculator is exactly the same as what's on my page. I'm starting with the negative, the minus, and I get negative 4.09. Or if I change it to a plus, I get like so. 31.09. Okay, so I've done my calculating and I've checked my working, and now I'm going to go back and read the goal again. The goal was to find the height of the mirror, including the frame. So what have we got so far? Well, we've got two different values for W. So obviously it can't be the negative one, so because we know the width has to be positive. So let's write that down. So W must be positive, so width is 31.09 centimeters. I still need to write both solutions initially. That's part of what's in the marking schedule, but then I need to identify the positive one as the valid one in this case. Okay, and the height was what we're after. So what do we know about, how do we go from width to height? Well, we know we times it by 2. So timesing that answer by 2, and that's going to give me the height just of the mirror part. So let's write that down. So 62.18 centimeters. And then I've got to remember the goal, which I drew at the start, was the height of the whole thing, including the frame. So how much do we have to add to take the frame into account as well? Well, there's 9 centimeters at each end, isn't it? So it's going to be not plus 9, it's going to be plus 18. So let's write that down. So total height equals 62.18 plus the 18 for the frame, and that equals it's not going to let me pause it, unfortunately, so you're going to have to bear with me while I type it out. Plus 18, so 80.18 centimeters should be our final answer. And always check that it's sensible. That's quite a big picture frame, isn't it? Nearly a metre. But it is in fact correct. And if we go through and check our working, which is good if you've got time, then, because remember in the exam, it's top-down marking. So anytime you get one of these questions right, that's worth 7 points. So it can be better to check your excellence questions that you know you've done well at the expense of some of the achieved questions, if you're really pushing for that excellence. Okay, let's have a go at, well actually before we move on, let's just look at what you'd need to have in there. So you'd need to have formed the algebraic equation, and a key part is that you have got this one up here and that you've ended up with this equation here that we can then solve. So this line of working I've just ticked. And then we've showed how we've used the quadratic formula. We've got both our solutions. Do need to write them both down, even though the negative one's invalid. Still got to write it. But then we identify that why the positive one's the only valid one at the step here that I've underlined. And then we've showed our working to our final answer, which is here. And so that would be a T, in other words, excellence. Okay, question E. The roots of the equation x squared plus x plus 2 equals p times x squared minus x minus 2 are real. What is the range of values for p? Okay, so this is a really common sort of question, and as soon as you see that word, well, the two words roots and real, then it means we're going to be using what? What part of the quadratic formula determines the nature of the roots? And it's the discriminant, isn't it? It's the part of the quadratic formula here that's under the square root sign. Because remember, the easy way to remember that is that you can't have a square root of a negative number if the answer is going to be a real number. So that's how we know it's the bit under the square root sign. So the first thing I'm going to do with a question like this is I'm going to think about the goal. The goal is, so to be real, the discriminant, which we use that sign there, that must be what? Well, it's not real if the discriminant is negative. So therefore, as long as the discriminant is same or greater than 0, then we're going to have real roots. And if it equals 0, we're going to have one repeated root. And if it's greater than 0, we're going to have two roots. So as long as it's at least 0, we're going to have real roots. So let's write that down. So b squared minus 4ac has to be greater than or equal to 0. Now, the next thing we've got to do, that's our goal. The next thing we've got to do is we've got to get it into the form where we can use that. So we need to get this quadratic equation here into the form ax squared plus bx plus c equals 0, so that we can pull out the a, b, and c into our discriminant. Okay, so how do we do that? Well, I want you to pause the video and have a go at arranging this equation into the form ax squared plus bx plus c equals 0. Go ahead. Okay, first thing we do is write it out. So we've got x squared plus x plus 2. And when we get to the brackets part, we can expand those, can't we? So equals px squared plus, minus px minus 2p. Okay, so we've expanded those out. Now, we need to get it, remember, into that form that I put in blue. So we need it to equal 0, don't we? So therefore we need to subtract, firstly we need to subtract px squared from both sides. So that's going to be x squared take away px squared, isn't it? Now, the next thing we've got is a minus px. So we have to add that to both sides, don't we? So that's going to be plus x plus px. And then we need to add the minus 2p. We need to add 2p to both sides, don't we? To get rid of the minus 2p. So plus 2p. And that equals 0. Okay, let's step back and have a look at what we've got now. Okay, so if we look at the terms, we've got an x squared term, we've got an x term, and we've got the numbers or the constants. P is actually a constant. It's not a variable, it's an unknown constant. We've got to work out what it could be. So starting with our x squared terms, remember we want to get into the form ax squared. So we need to factorize that and write it so it says something x squared. So something in brackets times x squared. What's that going to be? Well, it's going to be 1 because it's 1x squared minus p because it's px squared. Okay? So that means our a value is just 1 minus p. Alright, next we move to our x terms. What I want you to do is pause the video and see if you can do the same thing with the x terms. So it's going to be something times x, isn't it? Alright, and we've got 1 times x plus p times x. Okay, and then the next thing is, what do we need to do is the constants, things without the x. So that's going to be what? It's going to be plus, now I've got 2 plus 2p, so 2 plus 2p, like that. But actually I can, when I look at it, they've both got a 2 in it. So it's going to be easier later on if I just factorise out the 2. You don't have to do it that way, so it's not a crucial step, but it does make it easier. So generally if you see something in a problem like this where there's a common factor, it's often easier to factorise that out. So what I mean is I'm going to write that as 2, that last bit is 2 lots of 1 plus p. Okay? So now I've got my a and my b and my c. So we've got ax squared plus bx plus c equals 0. So let's write out what a, b, and c are. So a equals 1 minus p. B equals 1 plus p, and c equals 2 lots of 1 plus p. Okay, good idea now to read the goal again. What's the goal? Well, we've got to find the range of values for p that mean that the original equation here has real roots. So then that means we want the discriminant part, b squared minus 4ac, to be greater than or equal to 0. So what should we do now? Well, let's set up the discriminant. Okay, so the discriminant is b squared minus 4ac, right? So what's b? b is 1 plus p. So 1 plus p squared, in brackets, minus 4ac, so minus 4 times a, which is 1 minus p, times c, which is 2 lots of 1 plus p. So b squared minus 4ac has to be greater than or equal to 0. We need to find the values of p that make that work. So we've now got really a quadratic equation inside a quadratic equation, which is a really common excellence thing they do. Okay, pause it and have a go at solving for p. Go on. Okay, so what I'm going to do first is I'm going to simplify it. So when I look at the bit on the right there, what can I do with that? Well, I've got a 4 times 2, so I might as well just call that 8. So then I've got minus 8, then I've got 1 minus p, 1 plus p. Now, what can I do with 1 minus p, 1 plus p? You should know this. It's a difference of 2 squares, isn't it? So if I expand and simplify that, it's going to end up being easier to handle. It's going to just be 1 squared minus p squared, or in other words, 1 minus p squared, isn't it? So that's going to be like that, which is going to be easier to handle. So let's rewrite it like that. So I've got 1 plus p bracket squared minus 8 lots of 1 minus p squared is greater than or equal to 0. Okay, what shall we do now? Well, let's expand the brackets. And remember the 1 plus p in brackets squared bit means 1 plus p times 1 plus p, doesn't it? So I've got to go 1 squared, or 1, plus 1 times p, plus p times 1, so that's going to be plus 2p. And then last times last is p times p, so plus p squared. Right, so expanding those brackets out. Over here it's just going to be, it's just one set of brackets, so it's just going to be 8. So minus 8. Now there's a double negative here, so you've got to be careful. Negative 8 times negative p squared, so plus 8p squared is greater than or equal to 0. Okay, now I need to get it into a quadratic equation in simplest form, don't I? So again, I want ap squared plus bp, not the petrol station, plus c. So let's do that. So p squared terms, we've got p squared plus 8p squared, so that's going to be 9p squared. And then we've got our p terms, which is just 2p minus 7 is greater than or equal to 0. Now, I can actually factorise this. I could use the quadratic formula, but it's going to be easier if I actually factorise it. Always just check, because if I go 9 times negative 7, I get negative what? Negative 63. And I need two numbers with a difference of 2 that multiply to 63, or negative 63. Are there two numbers with a difference of 2 between them that multiply to 63? Yeah, there are. There's 9 times 7, right? So I can split the 2p up into 9p minus 7p. Can't I? Minus 7 is greater than or equal to 0. Right, I'm just going to tidy that writing up a bit. Right, and factorising these parts separately, I get what? 9p p plus 1. And then over to the other side, it's going to be minus 7p plus 1. And then we'll just move up here, start a new column. So if I fully factorise that, what's it going to say? Well, it's going to say 9p minus 7 times p plus 1, and that's got to be greater than or equal to 0, doesn't it? To have real roots in the original equation at the start. Okay, so let's think about what that's going to look like. So it's a parabola, isn't it? If we did the graph of p, then it's going to have, you can see it would be 9p squared, so it's positive. It's a positive parabola, so it's smiling. And what are its x-intercept? Well, its p-intercept is going to be. So it's going to be 0 when p is -1, alright, or when 9p minus 7 equals 0, so 9p equals 7, so p would be what? 7 ninths. So its two x-intercepts are going to be at -1 and at 7 ninths, so just short of +1. So if we sketch that, it would look like this. And we want that to be greater than or equal to 0. So when is that greater than or equal? When is that green curve? When is it at or above the horizontal axis? So it's everywhere to the left. Well, it's everywhere -1 and to the left, and 7 ninths and to the right, isn't it? So P must be less than or equal to -1, or P must be greater than or equal to 7 ninths. And so if that happens, then just rewinding big picture again, what does that mean? Well, it means that in that situation, the discriminant is going to be greater than or equal to 0, the original equation, because that's what this represents. It represents the discriminant. And if that's the case, then the original equation right back at the start is going to have real roots. So that's the answer. Now, in their answers, they've said they haven't put the or equals to, but I actually disagree. I think that because the question says for what range of values will the roots be real, and when there's one repeated root, you still would say that's real roots. So I think the best answer is this one here. So P is less than or equal to -1 or greater than or equal to 7 ninths. And so that's another excellent question. It's worth practicing these. There's a section on them in your Walker Maths book if you haven't done them all, and also in theta. They're really common. And the key is that first step is to set up the goal. The goal is to make the discriminant greater than or equal to 0. So that writing that first is a really useful trick. Okay, see ya.